Yes.
So today I'm going to talk a little bit about generators. Generators usually yield values, but you can also have them return a value. And what does that mean and how does it do that? So here I have an example first in this cell here of a generator function. What this generator function does, it returns a generator. The code that you see in the body of this function is not the code that the generator function executes, but it's the code that the generator function returns executes. So I'm going to instantiate one generator, and then I'm going to call next on that generator 10 times and collect all the values into a list. And you see a list with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I do that again, I get the numbers from 11 to 20. The generator maintains state. If I want to reset the generator, I can't really do that, but I can generate a new generator and let the old one be garbage collected. And when we call next 10 times, we get the list starting from 1 again. So this first example of a generator, it never returns. It has an infinite loop. So if you want to have a generator that returns, that exits, we can put a bound on this generator. So here's a new generator function. And I'm just going to collect all the numbers that this generator yields into a list. And we get the numbers in this case from 1 through 10. If we call next more times than the number of values that the generator yields, we'll get a stop iterator. So this generator G is going to yield numbers from 1 to 11 exclusive. That's 10 numbers. If I call next G 11 times, we'll see a stop iteration. What happens if we add a return statement like here? I'm going to sum up all the numbers that the generator yields and return the total. And I'm going to do the same thing. I'm going to call next on this generator one more time than the numbers or the number of items that this generator yields. And here you notice that the stop iteration has a value 55. And this value 55, that's the sum of all the numbers from 1 to 10. And so that's the number that this generator returns. So if we are interested in that particular value, we can just put the call the generator next G inside a try except statement, like here. And we see we catch the stop iteration and we extract the value of this stop iteration, and we can then print it. The generator returned 55. There's another way we can get that value, the return value, is using yield from. Yield from evaluates to the value returned by a generator G. So this from generator takes a generator, yields all the elements that G yields, and then finally it also yields the value returned by G. And so if we collect all those values into a list, we get the numbers from 1 to 10, which were the numbers that G yields, and then 55, which is the number that G returns. So are there any practical uses? I believe there are. So I've given a presentation a long time ago on group by. So there I focused on this function group by that is in itertools package. So let's say I'm given a number, an iterable of numbers, nums, and I want to sum them all up. That might be a daunting task. So I divide this task into several subtasks. So I'll split the numbers into groups and I'll sum up each group. And then I'm going to yield whatever these groups yield. The yield from will yield the return value from some group. Will evaluate the return value of some group. And I'm going to add it to a grand total. And finally, I'm going to yield a string with a grand total. Some group takes a key and a group. We collect all the elements of this group in a list. We sum up all the elements in a group total. We yield a string, and then we return the group total. Finally, we can see what happens when we print all the elements of sum all. So here we see the strings that the different sum groups yield. And finally, the grand total here that sum all yields here. So I think this is a very nice way to modularize. I mean, this is simple, but you can have more complicated, more complex tasks. Let's say you want to build an HTML page and you have different generators for the different parts of that HTML page, and you want to collect all those parts into one big generator that generates the whole all the lines of that HTML page. So if we're not going to use generators, we could have used regular functions, and we could have printed these lines as part of those functions. And then we don't have any generator functions. That might seem simpler. Notice that the code is almost the same, so it's not any simpler. Instead of having yield, we have print. And that's about the only difference. To me, this is a bad way of structuring code, because here you're locked into printing these strings. Whereas when you use a generator, you can do whatever you want. You can collect all these strings into a larger strings. You can print them out to a file. You can send them over a socket, or you can just print them to the terminal. It's also much simpler to test. If we were going to test these functions here, these sum with side effects, we would have to capture the printouts. And there are test tools for doing that, but that's just adds extra complications. Whereas a generator function is really simple to test, because they are pure functions, and a pure function is something that takes an input, returns something, and does nothing other than that. So if we take, for instance, sum all, it takes an input nums and it returns a generator. And all we need to do to test this is to make sure that that generator generates what we expect it to generate. So here I have an example. We want to test a sum group. We have an iterable of 2 elements, 10 and 13. And when we collect all the elements that sum group yields, it's just one element, we can then verify that we get what we expect. If we want to test the return value, well, we know that that return value is passed in the stop iterations value. So all we need to do is to repeatedly call next until a stop iteration is yielded, and then verify that the stop iterations value is what we expect. So we can do the same thing for if you want to test what sum all yields and what sum all returns. Sum all doesn't have an explicit return statement. In that case, when the an iterator is done, when it exits, it returns none, and we can verify this here. So that's all my talk. I'd like to summarize, but I want to do it in the form of a poll. So I talked about generator functions and generator. And if you go to your reactions buttons and you press on that, and there's a green check mark and a red X. If those who want to answer yes, they can press the green check mark, and those who answer no, they can press the red X mark. And then we can just do a count. So only David has answered. We have 2 yeses, Sarah, 3, 4. Don't be afraid of answering no. I mean, 1, 2, 3, 4, 5 now. 5 yeses. And I'm just going to assume that the rest are no's. How many are we? We are 12. So 7 no's.
Don't forget to count yourself.
Yeah, you are counting.
Oh,
yourself.
I have counted myself. So just 6 then. Have I counted correctly? 6. Oh, it increases 6, 5. Okay, so the next question is, did you know that you could have a return statement in the generator function? Yes or no? No. No, no, 3, 4, 5, 6. 6 no's. A lot of no's. Surprises me. And then I guess the rest of our yeses. Yeah. Then generators return a value in addition to yielding values. Who knew that? Who did not know that? 1, 2, 3, 4, 5, 6 no's. Again, the same thing. So you learned something new, I hope. The return value of a generator is passed in the stop iterations value attribute. Anyone knew that? No, 1, 2, 3, 4, 5, 6, 7 this time. And I guess the total is 11, so that is 4. That yield from G evaluates the value returned by G. Anyone knew that? 2 people knew that. That's good. And no, yes, no, 3 people knew that, or 2. And the rest, I guess, 9. And you can use generator functions to avoid side effects. Yes, there's 1, 2, 3. Any higher? 3, and then I guess 8 no's. Well, that concludes my presentation. Over to you, David.